Okay, so big idea number one, writing ions and determining charge. Sodium 2+ would be an example. We're really analyzing your understanding of neutral versus non-neutral atoms. And if you lose electrons, you become more positive. We call that a cation. You take on a positive charge. If you gain electrons, okay, you add it to your original neutral count of electrons. You become more negative. Okay, you become an anion, a negative ion, right? And an ion is what? What's an ion? What's the simplest definition for an ion? Mary? Yeah, a charged particle, a particle with a charge. Okay, that was big idea number one in the first set of questions for both versions. Okay, the setup was the same. Okay, big idea number two was counting total electrons. Okay, and then comparing total count for neutral versus non-neutral. So again, another, right? We're sticking with this idea of playing around with the atom. What are the subparticles we can change? We never, ever, ever touch what? Proton count, exactly, proton count. But we can touch mass, neutrons, and charge, electrons. So today's or yesterday's quiz was talking about the electron messing around. We've already quizzed you on isotopes, playing around with the mass, the neutron count. Now we're having you play around with the electron count, okay? For neutral versus ion or versus charged, okay? And by the way, the implicit skill in all of this was that you also had to remember how to write element names, right? Write symbols. Remember when we write chemical symbols, okay? A capital letter represents a new element. So I got a lot of people writing calcium like California. No, that's carbon in a non-existent atom. You just wrote a compound. You wrote a bond. We're not there yet. We will be, but we're not there yet. Okay. Next set of skill was reading the periodic table. Okay, reading the periodic table. Ooh, apparently reading my own handwriting is also a skill. Reading the periodic table. I gave you like a bingo set. If you go to group number, what you're looking for a group number is column number. What column am I supposed to be looking at? Right? And then I gave you a row or what we call a period number. Okay. Which one am I looking at here? And you had to find the crossover to find your element and identify it. People apparently had really struggled counting. Okay, that was the front page. A lot of you guys wrote that as the back page. So that was actually the front page. The next skill you guys had, which was the hardest one to grade, was your trends. And here's the big thing. Everything stems from Coulombic attraction. You cannot explain the trends without explaining Coulombic attraction. Okay, Coulombic attraction is the attraction between a positive and some negative particle. What is the positive particle for us in chemistry? Mika. The protons. What are the negative particles for us in chemistry? The electrons. So that was the root of everything. When I said explain why it's increasing or decreasing, you had to talk about Coulombic attraction. Simply restating your arrows was not enough. I can read your arrows. That doesn't tell me that you know why. Okay, so the idea behind Coulombic attraction is that there is a pull from the positive protons to the negative electrons. And that pull, okay, that pull connects to a couple things. It tells us why we see certain atomic radius, right? Size of atoms. It tells us why certain atoms have more ionization energy or less ionization energy. right? Stealing, the energy required to steal. And it tells us also why we see some atoms really good at pulling other atoms' electrons, electronegativity, right? Other electrons, attracting other electrons, right? And so what I asked you to do in the quiz was, given the general periodic table, draw arrows to represent the trend lines and then explain. There are two things that affect Coulombic charge. The first is, or Coulombic attraction. The first is the actual charge, or the number of protons. The second is the distance in terms of energy levels. Electrons occupying energy levels, or rows. Okay? And those together impact the Coulombic attraction. Now, there was an equation. The force is equal to some constant times charge 1, charge 2 of particle, or the overall charges that you're working with, the little magnitude of charge, right? And all over r squared. What we see is that charge versus distance. Charge increases Coulombic attraction, but distance decreases Coulombic attraction exponentially, right? So those were the big ideas that you guys were addressing. And then you had to verbalize it in such a way that it was obvious you knew more than memorization. You knew more than just putting a mental picture in your brain saying, this sounds like what she said in class. Okay. So that's my overview for you as we take today to get everybody on the same page. Okay. So leaders, what I want you to do is right now you're going to go through and you're going to have each person, you're going to, as a group, analyze each person's quiz, particularly what they got wrong on the explanation point. But if you have time, go back to the ion thing, okay? And group leaders, when you analyze as a team, each person, why are there so many people at that station? Four, how many are your group? Is it 5? Wait, how many are your group? 4? You're at that group? Okay, that makes so much sense. I thought you were by Vice's group. I'm like, why are there so many people? Okay, what you're gonna do is as a team, you're gonna go through version 1 people. So you'll pull out version 1 people, leaders, you wanna grab a marker, you're going to lead the group through the discussion of what they went wrong. Everyone's gonna give feedback. And then leaders, you're going to make up questions and I'll put some on the screen for you or here on the board to test everybody, to make sure everybody has the skills that they need in each section of the quiz. And then you'll switch over to version 2, where you go through and you say, hey, I like what you said in that, but you're missing it. And then you're going to go through and group critique. The idea is to help lift each other up to the right answer, not just completely shoot each other down. Trust me, they already feel shot down by stuff of my grading. Okay. So that's the goal. You're going to get 10 minutes to just go through every person's quiz with a minute comb. And then leaders, I'm going to have prepared questions for you to walk, new questions for you to walk through with your teams, and your teams will construct answers. And then teams will rotate and switch with one another to analyze how well the team understood it. All right, 10 minutes on the clock. You may begin.